I hope you can all see my screen now. Okay, okay, that's great. I don't know if there's someone who has joined us. Okay, so let's proceed on today's concept. So this week, we're going to introduce SQL and Postgres because it's the package that we'll be using for this course. And I know you've been working with the in-memory storage and which crashes every time you refresh your or you restart your server. But we're going to solve that problem and introduce now us to SQL. I don't know whether there is any one of us who have worked with these databases before. Anyone who have worked with any database before?
I had worked with databases in the learning projects. If
Yes.
I'm not mistaken, that was like MongoDB or MySQL, something like that. But that was several years ago. But at least a little bit I have understanding what that is.
Okay, okay, that's a good one. So we have different types of databases. We have these SQL, which is a structured. Uh, sorry, we have different types of databases. We have relational database, which stores data in forms of tables and columns, just like Excel sheets. And then we have non-relational databases or NoSQL databases, which include the one you just mentioned, MongoDB, which stores data in a format like closely mirrors JSON object. So, but for this one, we're going to do the relational database, which stores data in form of tables and columns. And now the SQL is like a language, or it's the query language that now allows us to query the database and interact with it. The others are just database management systems, and we have quite a few. We have MySQL, we have this Postgres, and we have others like MariaDB, etc. So, uh, been working with these global.users and global.task, but now we are going to look at this SQL. And so why SQL matters is that SQL database store your data permanently, which survives server restarts and scales beyond a single process. The foundation of every backend frameworks build on these SQL databases. And as you've seen with your current project or at the state at which we are at now, you can only a single user can access your application at a time. But now when we integrate a database, it allows multiple users to use your platform. So these are what you're going to do. We've just looked at what you've been using, and in week 4, we introduced validation, and then we had validation. I can't remember all the topic of it. Had validation and the other, but today we're going to discuss why we use databases, and then we'll look at SQL basics. I will discuss associations and transactions, and then we'll look at joins, and we'll discuss how to use Postgres in Node environment. We'll discuss parameterized queries and their security implications, and then I will just have an assignment preview. I asked whether all of you have or anyone has worked with the database before. We got an answer. And then we've seen that when you restart your server, when using in-memory storage, your server crashes or you can't access the users. So that is the main problem with in-memory storage. That is database disappear when server restarts, and it can scale to multiple server instances. That's why only one user is able to access your application. And then we have it is limited to the available RAM on your device. But for these now databases, we things have uh, become easier, and we can access more cloud databases easily, which scales and are also cheaper because you pay as you use, as opposed to earlier instances where you had to pay for a database and maybe you could end up paying for more space that you don't use. So database now fixes these issues, and because data is written to a disk and survives restarts and can be shared safely across many server processes at once. Look at a platform like TikTok, it has millions of users. Look at another one like Facebook or AliExpress, the Amazon. All this is enabled by database. And we discuss about the databases. We've said that they store data in forms of rows and columns, just like the way we have, I believe all of us have interacted with these SQL, not sorry, with the Excel sheets, and the way we have different columns and rows. That's just the normal way the relational database works. And they have the columns, which stores the fields such as ID, name, email, password, etc. And then we have the rows. The rows, sorry, which is a record of each. Uh, then we have constraints. We look at them. These are rules about the data, and which includes, for example, not null. We have unique. Look at instances where you are storing a username. You should not store the user when the username is blank, or let's say when the email is blank, and we check at constraints that ensures some details are unique, such as the email, because you don't want a user to create multiple accounts with the same email. Then we look at foreign key. These are this is how this is how tables relate to each other in our database. And we also have a primary key. We look at that. So sorry, I had another a bit detailed slide that I wanted to share. Yeah, I think this one. I hope you can all see this slide. I had created another one which is a bit detailed. So, okay. But we'll mix through the two when I feel like there's a concept missing in the one I was just sharing. Yeah, I just wanted to elaborate the primary keys and the foreign key. So a primary key uniquely identifies each row in our tables, and a foreign key links a row to another row in another table. This is how we join tables and access data from different tables by merging them. For example, at this order table, we have the create table orders, and then we have the ID, serial primary key, and then we have user ID, integer references user ID. So this user ID here is a primary key to this orders table, and it it's a primary key in the user table. So we reference it here so that we can relate now the users with these orders. Yeah, and then we have the constraints that we were talking about. A primary key is a constraint which uniquely identifies each table. And then we have other constraints such as not null. We have other constraints such as unique for maybe fields such as password. Okay, so let's switch back to this. I'll be switching back and forth. So we have some of the SQL verbs that we'll mainly use for or in all databases that we work with. So we have these key verbs, which are select, which is mainly used to read data. We have insert, which is used to add data into the database. We have updates, used to change data, and then we have delete. which is used to remove data, and we have verbs such as create table or drop table to manage structure. I hope you can relate these verbs with the CRUD operations or the major APIs that we have in our REST APIs, or the major methods that we have. We have post methods, we have the delete method, we have the patch or put method. I hope you can relate these to them because we'll be working with the roots. So then this is an example of the use of this. So these statements, so this query selects everything. The asterisk is used to select everything from the table users. So this will return all users in our database. Uh, as illustrated above, that's for getting all users. And then to get specific columns, you can just select the columns that you want instead of using the asterisk. For example, select the name, email from users. We also need to pass the where clause. This is for specific fields because the first statement just returns all the users in our database. But for this one, we need to select with the where clause, which now helps us to filter or to isolate a specific user. And then we look at some verbs, some methods that are used for sorting and limiting. For example, select everything from tasks, and here we order by created at in descending order. That means from the latest to the last to be created, and then we limit to only 10 tasks. So these are keywords also that we'll be using when we interact with this. So we have a disclaimer here that the where clause filters rows. Without it, on delete, you delete everything. So always remember that whenever you are writing a delete, sorry, wherever you're writing a delete query, remember to include this where clause, because if you fail to do that, it just erases everything from the database. Yeah, we'll also, those are selects, we have the insert and update. So insert is used to add data to a table. For example, adding a new user. So we'll use the insert into users, name, email, and then we pass in the values. For example, here we have Alex and Alex at test.com. And then to update a task, we use the verb update and then task with the set, the field we want to update, giving it its value. And then we also filter with the where because we need to update a specific task. So we filter with the where clause and filter by ID. And then now you when you are returning your let me see. Well, you are returning your tasks, or you used to sanitize your task, but we'll see these. We'll see these. We will see this return keyword, which this returning verb, which now allows us to return specific fields after we've created or updated or deleted something from the database. So remember that the returning only works with delete, insert, and update, but it doesn't work with select. Remember that. So for example, here we have for update, we could update a task and then return maybe the title, for example, the ID, title, and maybe is completed. Yeah, so for this one also we are returning the ID and title. So the return now, instead of the way you are doing the sanitization for when you create a task, for example, here the way you are sanitizing the task, you could just, we'll look at that when we incorporate these Postgres in our application. We'll explore the returning word, the returning verb. We've talked about foreign and primary key. And then we'll talk about something else, which is associations. Let me use this slide for that and discuss the different associations that we have in this relational database. I don't know whether there is a question. Anyone with a question, or if I'm moving too fast, you can ask. So we have different types of relationships or association, and every relationship between two tables fall into one of the three shapes. So we have a many-to-many relationship. For example, one user may have many orders, and for example, in our case, one user may have many tasks. So the foreign key lives on the many side. That is, for example, in the example I showed here with the orders, we had this foreign key living inside this orders table. So we have that one. So the foreign key lives on the many side, and for instance, in our assignment or in our tasks, the foreign key will live in the tasks, and that will be the user ID will be the foreign key to the tasks table. And then we have a many-to-many association. For example, let's take a case where we have students, and students can have many courses, and so these ones we use a joining table. We'll look into this, but your assignment doesn't have much of a many-to-many association. But this courses case illustrates it better, because one student could have many courses, could be enrolled in many courses, and many students, the courses could have many students. That are many-to-many association. And then we have a one-to-one association. For example, the way we were saying, we enforce the unique constraint to ensure, let's say, a user could only create one account using a single email. So that is a one-to-one association. For example, this one, a user has one profile enforced with the unique foreign key. So those are the different associations that we have in SQL. Good, illustrated them. And your assignment also talks about, let me log into the Lands app. Your assignment also talks about these transactions. And a transactions ensures that multiple operations all succeeds or fail at one. And we write a transaction using the begin keyword, and then the transactions that we want to conduct, and commit them. So for example, if let's say we were running our database, and our laptop or our server goes down only when we had processed the first update, that is update account set balance is equals to minus 100, where ID is equals to 1. So if the server maybe crashes before the second is processed, then the database rolls back, and these two updates all fail, instead of having a scenario where, let's say, we deducted or we charged one user and then the amount never arrived in the second user. So to preserve integrity of data, we just roll back to the original state the server was in. So that's all about transaction. It just ensures that both both updates or both operations complete, and if none fails, all of them are just rolled back to the normal state. So for example, I've explained that. We'll also look at joins. We've said joins is how we join different tables and or how we combine data from multiple tables. So for example, and we have three types of joins, ones that I want you to have a look at your own free time. We have inner joins, we have outer joins, and I forgot the differentiations between all of them. I took these database lessons, I think when I was in second year. I can't remember the definitions clearly, but I would like you to have a look at them. So, for example, this is how we join the data from multiple tables. So, for example, here we are selecting tasks.title and users.name from tasks and then joining the user table. So, joining the users on task ID is equals to user ID. And we filter by a particular user. Let's say this is a user who has logged in. We filter by their email. So, where email is equals to alex@test.com. So what this does, it just selects this field, the title, the tasks.title, and this is now the task title are in the tasks table, and then the user.name is in the users table. So we are joining these and returning them to the user or returning this from the query. So we are joining these user table where the task ID matches the user ID and where the email is equals to that. So join matches row from each table using the on condition. Without a matching in the inner join, the row is excluded. So where there's no match, it won't return any data. Okay, so let's now see. I hope I've covered these uh, in a way that you understand them. I was trying to access your the Lens app. Let me see whether it is. I don't know whether there is a question or I was too fast. Okay. Okay. Sorry, I should have done this earlier. Okay. Let's. It's weird. Okay. Let's just continue with how we add Postgres in our database. So you install it using the PG package. You've been when you installed the or when you cloned this repo, you installed all the dependencies, but you just install it using the command npm install pg. So that one now installs Postgres, but when you excuse, when you cloned this up and installed all the dependencies, it was included in the install. So the way we use this now PG, we use a pool. That is, we keep a connection to the database instead of opening this or instead of running individual queries as per user request, we just keep a pool which keeps some connections to the database running and which are used at request as per user. So we just import it. It's just installed. So we just import it. In your assignment, you'll be required to create a folder name DB and the file load db.js. So we require the pool. The const pool is equals require pool, require PG. You also need to read this database URL. You've been writing these in your setup while you are setting up this repo. And also remember that you'll need to database URL because you'll have a separate database for the tests. So remember that you'll check through the assignments. So you need to read these in your loaddb.js. You need to use that, and so you require the pool, and then you require the .env.config to allow you read now this database URL, and it needs a connection string which includes the .env. This is the connection strings that we are looking at. It has the Postgres, that is the database we are using, and then it has, this is the database user. I'm using the default database user for Postgres, and then this is the, sorry, this is the password, and this is the local host. I also forgot the port. Don't remember the actual port for, is it 5232, 5432? I'm not sure about the port, but we also include it in our string, but it can also work without. But it's always good to include the entire URL. So we require these in the in this loaddb.js, and then we read the connection string from process.env.database URL, the one we saved in our .env file, and also remember to include this .env in your gitignore. You should not commit sensitive information to GitHub. So we also need to check on error while it could return errors on idle clients. So we need this, the pool.on error, and then we console.error the error, and then we export the pool. So we'll be using this pool across our controllers. For example, in the user controller, I was working on this, I was going through this before we lost power, and I haven't been able to go through the entire coursework. That's why maybe you might find I'm a bit fuzzy today. Didn't have time to check through the contents or what was required. So my apologies if some concepts don't come up clear, but where you need clarification, you can ask. So for example, in this user controller, we import the pool. So we require the pool from DB and load that. And we carry out the queries using now the pool.query. For example, in our register method, we have this. Okay, we do the normal. We conducted the validation, and then we'll be working with the value. So for example, I checked for an existing user using the await pool.query, and then wrote this query select everything from users where email is equals to this. We'll talk about parameterized query. Instead of just passing the email value from the value.email, we pass it using this the $1. We just parameterize our query and then pass them such that whenever SQL is processing our request, it doesn't process these directly to prevent SQL injection attack where a user can just run SQL queries from our this our user input from the user interface or from forms. So and then we check for an existing user by checking the existing user dot rows dot length. If not, if this returns a value, then we return the message that user with this email already exists. Okay, so then while creating a user, so we'll do still await pool.query, insert into users. We're inserting the name, email, hashed password. Also check how you name your password because we'll have a look at this. We'll have a look at the this user table and the task table. We'll have a look at it and you'll notice that for the database, we normally use the snake case. For example, instead of writing the normal way, you write the hashed password in JavaScript, you use the snake case at this one. So take a look at that. It's something most people forget. Okay, so we are returning the here we wait pool.query and then we send it to users name, email, and hashed passwords. So the value we still parameterize them and we return the way I was trying to explain the use case for the returning verb. So we are returning the ID, the name, and the email, and we pass the values that we want to pass now from the value.name, value.email, and value.hashed password. That is after hashing our password. I was trying to debug this one so we can ignore this. And then we return the user.row to return the user information from our register method. Then for the logon, we do the same. We just use the, we'll use after comparing the password and when the password matches. So we select the user just using the now. So okay, I didn't work on all the methods. So like for this one, we could do select a user. Yeah, here we were selecting the user. Yes, so we could use, let me replace. I didn't manage to go through all this, but we can do this together. So here we'll await a pool.query. And then we are selecting. Just, so select everything from users. Here we are. We're selecting by email. So email is equals to, and we parameterize the query. And we are using the rec.body.email from this. So, and if we don't return a user or the user doesn't exist, we return the 404 error. And then after that, we compare passwords. So we extract the user password from user.rows. These are the one that is returned by SQL, and we select the first element because it returns this array. So we select the first element and then we select the password from the hashed password from what's returned from the database. And then we compare the passwords so that if the password is does not match, we return the unauthorized error and we set the global.user ID Where is this? Let me first talk through this schema. Intro schema. Let me access it from. I didn't write the schema in this. I wrote it directly in the Postgres. So let me just access the lens up. I hope I'm not losing you guys. Are we still together?
Yes, we're still together. Everything is fine.
Okay, okay. Let me log into this. I'm a bit fuzzy today. Just tired. We didn't have power, and then I've just been up and down school. I'm graduating next month on 14th, so I was just going for clearance and didn't have time to prepare adequately for this class. But I hope I'm passing the concepts along. Yeah. I want to take us through the schema. Yeah, okay, here it is. So we have the user tables. It has these fields. It has the ID, serial primary key. It has the email. We said these columns could have different data types. For example, this zero is an integer, and then we have this is now a variable or sorry, it's a character or just strings. We have the constraint for unique and then not null. We have the name, varchar with the length of 30, not null, and then we have the hashed password field with that length of 255 characters, and then not null. We have the created at, we have the timestamp, and then not null default time, default current timestamp. Then we have the user tables. Sorry, the task table. We have the ID, serial primary. We have the title with the length of 255 characters and not null. We have this completed is a boolean. Uh, Not null and then default false. So each task we create will have a default value of is completed of false, and then we have now the this one now the foreign key, integer not null, and then the way we link them is using the references. We are referencing the user tables here, and we are picking the ID value. That's why we have the references users, and then the ID, and then created at timestamp, not null, default, current timestamp, and then we have declared the constraints that we have. We have task ID, user ID, and unique. Those were the unique was used for the email, and then we have them at ID and the user ID. Yeah, so this is an explanation of the schema. We have the serial primary creates an auto-incrementing unique identifier, variable length string with maximum 55 character, not null, cannot be empty, etc. So we were here, we discussed about how we incorporate Postgres in our node application. And I was trying to explain the way we now use the pool that we created. So for this case, we were at this excuse logon method. So we read the user, we select everything from users where email is equals to that, and that we extract the email from the rec.body. And then if not user, we return the unauthorized or not found. And if password comparison failed, also notice that we said that we'll only use the returning verb only on insert, update, and delete uh, verbs in SQL. But for the select, we just have to sanitize our user the normal way. Yeah, we have to sanitize that. We extract or leave the hashed password from the response object and we return the sanitized user. For the logo, we were just setting the logo.user ID to null. Also remember, because we updated our database, so the global.user ID will set it to the ID that we created in the database. So the global.user ID is supposed to be the users, the user dot rows, and then the first one being returned and dot ID. So that's we are assigning the user ID to the global variable, but we'll now resolve this because it is a security breach when we talked about security in the upcoming lessons. I think that is lesson 9, but that's how you use the pool in your application. So let me save that. Let's update this task controller together. uh, okay. Okay. Let's look at task controller. So we had that. So here we'll install, just taking you through briefly. So we'll need a const pool. Those are required. We need it from DB that. And then look at, for example, the create task. I'm just going to do this create. So we're creating this new task, so we can create it here. So you can say await pool.query. Okay. Oh, typo. So await pool.query. Okay. Then we are inserting. So insert into tasks. And then we are inserting the our record body is supposed to give us the title. Getting this. So insert into this task, we are inserting the title, we are inserting this completed. Those are the fields that we are supposed to, just confused, I don't know what's wrong with me. So we are inserting the title and is completed. Sorry about this. And then values, just pass these. So values, then we're passing them from the value dot title and value dot is completed. Okay. Why? Oh, what is? I don't know why the pool is being highlighted. See, line 24. Oh yeah. Okay. So line 24, we required the pool.
I think there's an extra curly brace on 24,
Oh,
line 20.
okay, okay, okay. Let me not doing that. I'm not saying the extra. Okay. Yeah, I just to write down. Let me see why I deleted that. I needed to close. No, close this. Let me undo. I don't know what I deleted by mistake. So let's require poll. Uh, then we come to this create. Let me just remove the entire task. So that equals to poll. Then we're just inserting, okay, I'm forgetting the await. I see. I see. So the sorry. So this pool is an asynchronous. It's an asynchronous function, and we use the await. So that's what was causing all that trouble. We use the await. All my functions here are just synchronous. So while updating, I'll need to remember that. So we use the async keyword and then await the pool.query. So we are inserting into tasks. We are inserting the title and is completed. Okay. Values, that one. Yes, so values, that one, and then we pass in the values. So we are passing the value that title and the value that is completed. Yeah, so for this one now we can use the returning keyword. Sorry. returning. We can return the ID, can return the title, and we can return is completed. Completed. And now can remove this. Don't need these. And we also don't need to sanitize because we've already returned that. And so we can just return the user either as an object or just as the normal row that's supposed to return. So we can just return the user. Sorry, here we're just returning the task. I don't know why I'm such confused. We're just returning the task and we'll return the task dot rows. Then we're just returning the first. So we can just try these ones that the ones that I have just edited, and you just work on the others while you're doing your project because of time. I don't know whether there is a question. So let me see. I saw another error somewhere in my roots. So you need this one. Okay, and yeah, I'll restart the server again. And let me look for Postman. I don't know whether there is a question, but I know today's session is a bit terrible on my side. Okay. Yeah, so okay, human postman is refusing to work. We remember my roots. Users and then so let me, I'm sure I have these users in the database. Um, Then we have the password. Let's see. So this is a get root. It's a post. Yeah, so these are being posted to the Postgres. Look at the 72. And you can see we're just returning the ID, the name, and the email as we we used in the returning keyword. We just return the Just returning that. And then if we log on and try to post a task, okay. Yeah, I see why that one is. We're going to do something on the logon. Just finishing in the next minute. Let me see. You've seen it's returning like everything, like even unnecessary fields. So I forgot something here. Is user controller. So when we come to our logon method, I'm sure I was not returning the required row. So here we're supposed to return, returning something else. So this one was supposed to be user.rows dot the first row. That one, let me just restart the server again. And yeah, so let's try the logon. It's solved. So you need to be careful with your selection, how you return these values from the database. I think I'll end at that and just try to post a task. And we'll have one with this title and it's completed to be false and oh yeah, forgot something also in our task controller. Okay, so what task, create task. Is this okay? We forgot to insert the user ID. It's a required field in the task. So we write that one, and this will return we're using the global dot user ID. That's our user of the current logic that we are using. I hope you are also learning some debugging skills as we continue. And if there's someone with a question, they can ask. Return, because I'm not using the other one.
You need to update the values query as
Yes, yes.
well.
Okay, okay. Okay, so insert into, we've updated the user ID. Yeah, yeah, sorry, I forgot that. Okay, good. I think everything is in place now. Let's restart the server and let's try to see. Yeah, we need to log on again. Well, okay, so this one is users and log on. So we have the title and is completed. And find password. Let me confirm this. Could be a spelling error. Is mine correct?
Did you need to update the URL?
Yes. No, like
It's it's going to users log on instead of create task.
oops. Sorry. Okay. Tasks. Yeah, it's working. Sorry about that. I think I'll end the class at that, and I hope, even though I've been a bit like almost disoriented, I hope I've taught something meaningful. And if someone has a question, can just ask before I conclude. You'll update the rest as you work through your assignment. Let me stop the share. Okay, thank you. I think I'll end at that if there is no question. You're welcome. Okay, thank you. Feel free to leave at your own time. Let me stop the share and stop the recording. I'll stay behind unless someone has a